Hello lovely people, welcome back to the next part of this video where we go through this paper 1. So I've got here question 39 which says shown is a sector of a circle, find the area of the sector, and you want to give our answer in terms of pi. So this is very typical in the non-calculator paper. Let's go. So how much of the circle do we have? Well, the fraction is 150 out of 360, and they're asking us for the area, so we multiply that fraction by the area of what the full circle would have been, which is pi times radius squared. The radius is 6, so pi times 6 squared. That's pretty much all it is. So 150 over 360, we can simplify that a little bit, so that's 15 over 36 times pi times 6 squared. We can do this in so many ways. So if I just put it like this, 15 times 6 times 6 over 36 times pi. Where's that come from? That's just the 6 squared. I'm finding smart ways of simplifying this. So I can divide the top and the bottom by 6, because you've got this times 6. So I've got just 15 times 6 at the top. And that's all over 6. And of course I can do that again. So that's just, times pi, of course. And then cancelling again, that just leaves 15. And then with the pi. So my answer is just 15 pi. Next question. Shown below is a right angled triangle. Find the exact length of the side labelled y. So I see here that, we've only been given one length, and we've got an angle, and we've got a side length that we're trying to work out. So this is this is trigonometry, basic SOHCAHTOA. So this side length is our opposite the 30 degrees. This is adjacent, and then this is hypotenuse. So of the SOHCAH and TOA, which of these triangles has both opposite and hypotenuse? Well, it's the SOH one, so it's sine. So we've got sine 30, and we've got our opposite, which is our y, and we've got the hypotenuse, which is 8 plus 10 root 2. Okay, lovely stuff. And then from this triangle, we can see that y is going to be equal to sine 30 multiplied by 8 plus 10 root 2. Now for this question, you do need to know, because it's non-calculated, that sine 30 is equal to a half. So that's a half multiplied by 8 plus 10 root 2. And applying that, well, a half times 8 is equal to 4. A half times 10 root 2 is just 5 root 2. So it's 4 plus 5 root 2. And that's our answer for y. That's the exact length. So leave it in terms of surds. Next. The cuboid and the triangular prism have the same volume, and we want to find x. Well, the volume of this is going to be the area of the cross section, which is this triangle, and then we're going to times it by the length, which is this 20. So the area of the cross section is 8 times 5 base times height over 2, and then we're going to multiply that by 20. Okay, so that's going to be, 8 times 5 is 40, divided by 2 is 20. 20 times 20 is 400. Okay, that means that for this, we've got the area of the cross section, which is over here, 3.2 times 5, that's the area of that rectangle, multiplied by x, that's going to have to equal 400. Now, what is 3.2 times 5? Well, 3 times 5 is 15, 0.2 times 5 is 1, so 15 plus 1 is 16, so that's 16x equals 400, so x equals 400 over 16. So we can just simplify this, so it's 400 over 16, that's, divide them both by 4, that's 100 over 4. Oh, look at you, that is 25. So x equals 25. Next question. We've got here the cylinder above has a surface area of 400 pi centimeters squared, and we want to calculate x. Well, how do we work out the surface area of a cylinder? Well, you've got to consider that there's this circle at the top, circle at the bottom, and you've got this curved surface that goes all the way around. So first of all, we've got the circles. So this has a diameter of 2x, therefore the radius is going to be x. So the area is going to be pi times x squared, and we've got two of these. So we've got another circle, and that area, again, is going to be pi x squared. Then you've got this round bit. Well, if you were to open out this cylinder, it basically would be a rectangle, like that. And we can see here that the length or the height here is x, if you opened it out. And this length over here is actually the circumference of this circle here. It's the circumference because we open it out and that's the length that you get. So the circumference of a circle with radius x is going to be 2 pi x or 2 pi r. So 2 pi x. So there we go. That means that the area of this is equal to 2 pi x multiplied, that's the length, multiplied by the width, which is x. So that is equal to 2 pi x squared. Okay, so the total area like this is equal to pi x squared plus pi x squared plus this 2 pi x squared, and that's going to be equal to 4 pi x squared in total. But we also know that 4 pi x squared is equal to the 400 pi that they told us over here. Now we can start cancelling things. So divide both sides by pi, we get 4x squared equals 400. Divide both sides by 4, we get the x squared equals 100. So x equals the square root of 100, which is 10. Now we only consider the positive version because it's a length and length cannot be negative. So in case you're thinking, oh, but minus 10 squared also gives you 100, it's not right because it's a length. So we have that x is equal to 10. Right, let's carry on. Oof, fun times. We've got a vector question. Ooh, okay. Is ABC a straight line? Explain your answer. Okay, well, way we need to do this is we just need to work out what is the vector AB and what is the vector BC. That's what we need to work out. Okay, so what is the vector AB? So to get from A to B, we can go from A to O and then O to B. So A to O, we can see is 4A plus 3B. So 4A minus 3B even. 4A minus 3B. And O to B is 5A plus 2B. So 5A plus 2B. Simplify that, that is 9A minus B. Okay, then we have B to C. So we can see that B to C, well, that's going to be B to O plus O to C. Now, we can see that B to O, we're going against the arrow. So it's going to be the negative of 5A plus 2B. So that's minus bracket 5A plus 2B. And to go from O to C, we're going again against the arrow. So this arrow here. So that's again going to be minus bracket B minus 32A. Okay, so let's expand and simplify this. So that's minus 5A minus 2B, because the minus is being applied to everything, minus B minus 32A, so that's plus 32A. Be so careful with those negatives, they can trip you up. Okay, so simplifying that, we get, well, minus 5A plus 32A is 27A. We've got minus 2B minus B is minus 3B. But look at this. This is actually the same thing as 3, open bracket, 9A minus B. So they're both multiples of 9A minus B. So we say AB and BC are both multiples of 9a minus b. Therefore, they are parallel, P-A-R-A-L-L-E-L, and also they share point B. Therefore, ABC is a straight line. So we say yes, and that is our explanation. That's our maths, and that's how it works. Okay, next, a remote control car. Whoa, okay, a remote control car drives in a straight line. It starts from rest and travels with constant acceleration for 15 seconds, reaching a velocity of 10 meters per second. It then travels at a constant speed for 5 seconds. It then slows down with constant deceleration of 0.5 meters per second squared. Draw a velocity time graph. Okay, this is pretty okay. So we've got a velocity time graph, and it says it travels from rest, so we start at 0, 0, that is. Constant acceleration for 15 seconds, reaching a velocity of 10 meters per second. So 15 seconds is here, and it reaches a velocity of 10 meters per second. So I'm going to draw my straight line that starts there and here. There we go. Then we also have that it travels at a constant speed for 5 seconds. So from 15 to 20, like that. And then it slows down with constant deceleration of 0.5 meters per second squared, i.e. every second that goes by, it decreases velocity by 0.5 meters per second. So another way we can do this is, okay, so we want it to decrease by 10 meters per second, but we know that it does 0.5. It goes down by 0.5 every second. So it's going to take 20 seconds to go down by 10 meters per second. So we go from here down to here. So that there has a gradient of minus 0.5. So the idea is it's taken 20 seconds to go down by 10 meters per second. Now, part B, using the velocity time graph, work out the total distance traveled. Well, that's just going to be the area. So we've got here a trapezium. So we're just going to annotate this trapezium over here. And we can see that this has a length of 5. And the bottom bit has a length of 40. And the height is 10. There we go. So half the sum of the parallel sides times the height between them. That is how you find the area of a trapezium. So we have 40 plus 5 divided by 2 multiplied by 10. So that becomes 45 over 2 times by 10. So that becomes 225, if I'm not wrong. So 225 meters is the total distance that is travelled. Okay, next. A village is 20 miles from Belfast. Connor drives to from the village to Belfast at 40 miles per hour. Kelly drives from the village to Belfast at 50 miles per hour. Work out how much longer the journey takes Connor. Okay, so Connor obviously drives slower, so it's going to take Connor a bit longer. Okay, and we want the answer in minutes. Well, let's start off in hours and then we'll convert to minutes afterwards. So, well, this is useful. So, speed is distance over time. So, this little triangle is useful to us. Okay. So, for Connor, we want to work out how much time it took. So Connor time is equal to distance, which is 20, divided by speed, which is 40. So 20 miles divided by 40 miles per hour. That's going to give you a half, and that's the units is half an hour. So 20 miles mph, and then that gives us half an hour. And then Kelly time, so Kelly's rushing. So we've got the same distance, which is 20 miles divided by the 50 miles per hour. And that is going to give 2/5 of an hour. So 2/5 of an hour. So we could convert this into minutes now. So 2/5 of an hour is equal to, well, an hour is 60 minutes. So 60 divided by 5 is 12. Times by 2 is 24. So that's 24 minutes. And then we've got, of course, half an hour, which is equal to 30 minutes. So therefore, we do 30 take away 24, which is 6. So our answer is 6 minutes. Right, let's do another question. ABC is an isosceles triangle with AC equal to BC. D and E are points on BC and AC such that CE is equal to CD. We want to prove the triangle ACD. So triangle ACD is this one here. Is congruent to BCE. So meaning that they're exactly the same. Okay. So let us do that. Okay, so what would we have to write to get these marks? Well, what we could say at this stage, so ACD and BCE. So ACD, let's just color over that in blue and do the other one in red. So BCE. Well, we can see that, what can we see actually? Okay, so we know that CE and CD are equal. So CE, yep, CE is equal to CD. The question says, the info tells us, basically. So that's one side that we have. We have ACB, so angle ACB is common. It's the same in both triangles, so they have to have the same angle. It's common to both triangles. And what else do we know? What else do we know? Okay. So we've got CE, we've got CD, ABC, angle being common. What else have we been told? Well, it's an isosceles triangle. Yeah, it's an isosceles triangle. So we know that AC, is equal to BC. Because since ABC is isosceles, ISOSCELES. So we've got information there. So with that information, can we use that information? Yes, we can. Yeah, so we've got 3 bits of information there. So therefore, by SAS, side angle side, so that stands for side angle side, triangles ACD and BCE are congruent. And that is what you've got to say for your 4 marks. So that's it for this video, guys. I'll see you in the last part where we finish off this paper. Take care for now.